Hello, welcome to ALSO's Channel Trend and Vision 2021 and welcome to 3D printing from prototyping to production. I would like to give you a short overview today about 3D printing technology and the development over the last years. It will not be too technical, so no fear. And it's more about the aspects, what influences 3D printing and how can we use 3D printing more efficient for production and specific for mass production. My name is Uwe Becker. I'm responsible for 3D printing solutions in Europe. I'm a technician, an engineer by myself, so I have worked in that industry, and I would like to share a few of my experience with you now. So before we have a look into the future, we have to see where 3D printing is coming from. So developed in the 90s, the first printers were, and then we have seen a lot of development in terms of main technologies. There's not one 3D printing technology that fits all or that uses the same technologies. You can divide the technologies by their material and by their technique, how we combine material. And then in the 2000s, we have seen the first real main integrations in the industrial production, not in a mass production, don't get that wrong, but specific for prototyping and specific tools. And then in 2010, there was a hype about small private 3D printers for homes. And this is still a trend, but not a hype anymore, I guess. But this is an important element also for education, for schools, for classes, to learn how to work with that new technology. I think that is very important, and we from ALSO have a specific education program that supports that. And then over the last, let me say, 10 years, 15 years, we have seen that the printers get more and more efficient, more accurate, bigger, faster, a little bit like it was in the development of laptops or of phones. Yeah, we see a small ramp up phase, and then if many companies works on that topic, then the development is exploding. And that is very similar in the 3D printing development currently. So where we are currently, yes, I think it's a clear trend and a clear time for manufacturing with 3D printing and industrial general use of 3D printing. Does that mean 3D printing fits for all and replaces all the other technologies? No, of course not. But it is an interesting and flexible, good technology that helps some customers to achieve their goals. I have chosen one example of the automotive production cycles. What is important for automotive production is, of course, it has to be automated. That is based on their quantities we want to produce. And it has to be productive, of course. And the process has to be stable. And the quality is important. 3D printing today, or under a particular aspect, doesn't fulfill all these elements today, not alone. We need some other elements around 3D printing to achieve that. But 3D printing has very high design freedom, because you can design for 3D printing any tool or any part you want, independent of the complexity. This technology can print it. And it is very flexible, because you can just start with your 3D object and produce something. Another aspect that is important to 3D printing is that it can also change our production world or the manufacturing world. So instead of producing in one central point, it is maybe better to produce parts decentralized, where you need the parts, instead of having that one place to produce the things and then have all these transportation links to the areas where the final product is needed. So, and you are very flexible. I said that already. With 3D printing, you can print on demand. So instead of producing something for your stock or to your warehouse, it is maybe better just to produce something if it is needed. So these are important factors that makes 3D printing for production, industrial production, and mass production very attractive. But there is also one downside, because 3D printing for mass production is not very cost effective. Because one piece, and that's the horizontal line, one piece of printed costs the same as 10 as 100 per piece. Equally, it's a little bit different, of course, by the mass, but it has no big variations here. Versus injection molding as one of the traditional manufacturing processes, you have high tool costs when you start with one piece, but if you then inject hundreds, thousands or millions of pieces, the single price per piece is very low. So how can we then balance that? How can we bridge that gap? So we have to bring that cost line down. And I like to show you in the next slides a little bit what possible factors do we have to do that. And you think about 3D print center, where all the data flow into, and then you start printing and to scale your print with more and more printers, you also need more and more capacity, human capacity. You need to do all these steps, and that very easily brings you to a limit. That drives the productivity down. Not only the labor costs here, but there are a lot of steps in between which have to be done manually today. So 3D printing is not an isolated thing. 3D printing is part of a process workflow. It starts with the design. The design and how you design and how many designs do you do is an important factor. And then you have to prepare your designs for 3D printing, depending on the printing technology. And then the print is finalized. You need the post-process. You need to clean that, depowder that, color it, finish it. And finally then automation, or automated processes like packaging and sorting come into play. So you need all that combined to get a 3D printed process workflow. And I want to go to each of these elements today and show you how we can improve on what we have done already and what is available here. Let us start with the design. Normally, as an engineer, you would design a part on your laptop, on your PC, and do it with your CAD system. And then you maybe print it out as a prototype and check with if it is functional, if it works in cooperation and assembly with other parts. But generative design do something different. Generative design picks a few of your factors, picks your basic design, and does a lot of iterations to that. Generative design can create, in your behalf, hundreds, thousands of variations with small differences. And you as a user, as the end user, as the engineer, can choose the right one that fits to the technical needs and parameters, the right one that fits to your production process like additive, or the right one that fits really the strains or the physical parameters you want to achieve. And the software can then simulate that, and you can then finally print that. This shortens your time to market and your development process enormously. And to be honest, these generative design tools are so intelligent in the meantime that they can create things you not even can thought about. So this is a great opportunity, it's a great tool to increase productivity in 3D printing. So, and if you have then developed that, for example, a gear or a set of gears, a few hundred, you want then print them, for example, with a powder and plastic printer. And therefore the challenge is to bring all these 200 in this example pieces into that box that stays for the build space you have in your printer. And you can do that manually, of course, or you can use intelligent software products like from Materialize who do the job for you based on your rules, based on your parameters, based on your criteria. And in this example, and that is not a time lapse, it is live, this sort of organization of 200 pieces takes maybe 2 seconds. Done. Yeah. And again, this is live. This is real time. And you can set other parameters around. You can have them closer or have more distance or whatever you want. Yeah. So the system works perfectly and helps you to optimize your print space. And then it comes to printing of cells, the kernel, the thing itself. But the printer, honestly, in most of the cases, is a closed black box. The process in the printer is controlled, and there's nothing you really can do to that process manually. You load the job like this one, you just have prepared, and then push the start button and let the printer do the job. And a day later, you're done. But there are two strategies how you can scale. You can have either a big printer where you do all the parts or print the parts at once, or you have a small fabric of a number of smaller printers, which you can load also with different materials, where you do the job whenever the job is needed. Because for the other one, for the big one, you need a threshold on parts to make that really efficient and as a working 20x4 operations. And if you don't have so many parts to print in the beginning, it could make sense to have a smaller system and scale system by system with smaller systems. And also the material variations is an important factor to this. If you have the need to change material very often, or you want to use different materials in parallel, then I would say a number of printers, independent, small or big, could make sense. So the printer itself. So if you have finally printed that, then the part comes out of that powder. This is the left picture, just printed with all the powder surrounded, and you have to clean that. You have to get rid of that powder, and not only clean it, you have also to maybe smooth the surface or color the surface so that you can finally get your final object that is sellable, that can be sold. Otherwise, the raw printed piece is nice, it's functional, and if you install it somewhere where nobody can see it, it is maybe good enough. But most of the parts we have seen, most of the parts which will be used in industrial production processes will be seen and have a need and need to be colored, smoothed, and finished. And that is, by the way, also valid for traditional manufacturing processes. If you use milling or injection molding, there's also a post-process related to that. a different one, but a post-process. So Dimension, for example, as one of the brands in our portfolio, have perfect machines to do this cleaning job and do surfacing, smoothing or not smoothing, and do coloring. And important is also in coloring, if you have chosen a color, you want to make sure that in the next time when a customer orders the same part, you can achieve the same color. You want to have the same color, the same tone. And you need experts and you need an automated and controlled process to do that. And Dimension just announced their next step in the development, combined dual performance machine that can do the cleaning and the surfacing in one machine. And in addition to that, this machine is also able and capable to have an automated through or output of the parts, because that is important. What is the alternative? The alternative, where you may start with post-processing, is a sandblaster where you have the parts in your hand and do it one by one. But that is not very scalable. If you have hundreds and thousands of parts, if you have a number of printers and you have a production line, you need such systems to get that process piece automated. And that is the keyword, automation. It is not only that you have the parts and smooth them and clean them. In that print job, you can maybe have parts from different customers to make the print itself efficient. And then you have to sort them. But how would you do that? Manually? With AM Flow, we are in cooperation, or we have contact to a good partner who can do all that for you and as an integration to your workflow. So AM Flow can sort the part, can check the parts, can package the parts, and can check your orders and fulfill your orders based on IT data and order data that will be connected to this system. So this is a very important piece, especially if it comes to mass production for 3D printing elements. So don't underestimate that. I know that not all of our customers have today the need, but it's important that we have a solution for this and for a step that's definitely coming in the next evolution. So if you have all these steps done correctly, you get your 3D printing process and workflow with your automatic elements, generative design, materialized build processor who packs your build space automatically, the Dimension, for example, dual performance line who automatically do part of the post-processing, and finally AM Flow can automatically sort and fulfill and package your orders. Then you have your really full workflow with a minimum of human interruptions of handwork in that. But if you have a look a little bit deeper, 3D printing is only one puzzle piece, one element, one gear in this example to our solutions in ALSO. Because it is also not working isolated. It's not working isolated as 3D printing is not working isolated in the 3D printing process. And if you have a closer look, you see things like big data, connections, Internet of Things, and system integration, and of course automation. And ALSO is the best partner to support this, because we have all these tools out of our IT knowledge, out of our integration and services and solution knowledge, have all these offerings ready for you, ready to sell. And 3D printing is only an additional solution that for the manufacturing world can complete that. The ALSO 3D Solutions Center has started 4 years ago with distribution of HP multi-jet fusion systems, but we're doing much more than that. We have built a full ecosystem around that. I have shown you a few things already from that. We have services for this. We have, of course, the strong logistic and financial offerings here. So you can rent or lease the systems if you would like to. And we have, as a solution center for 3D solutions, a good relationship to the vendors, 3D vendors. We are looking always for new solutions. We try to combine them, we test them, and we have a community of 3D partners, which we are doing this business, of course, and we're supporting all regions across Europe with that centralized team. So if you have questions and if you're interested in that, we are happy to support you and we are happy to assist you for your project. So these are a few brands which we have around the HP portfolio, HP Multi-Jet Fusion 3D printing portfolio. And you will see very soon also other brands, other 3D printers, other scenarios coming up in this year and in the next years, which we have already identified, which we just in our onboarding process. So if you don't want to start back big, we have also solutions for you to ramp up smoothly, integrate or get an integrated step with services from our side into this solution piece. So if you're now interested to hear more about that, please meet our experts under the ALSO Tower New Business Ideas 3D Printing. And I would be happy to meet you there and answer your question. Thank you for your attention and have a nice day.